This is really responsive for being wireless too. It's really good. It's almost inappropriately good for the price, dude. All right, today we've got first impressions with the EinStar 2 and the EinStar Rockit. I'm going to be putting these things through their paces real quick and sort of comparing them to my experience with the old EinStars and the other scanners on the lineup, available for sale at visionminer.com/scanners if you want to pick one up for yourself, whether it's this one or maybe one of the more professional options. So let's check it out real quick. First impressions, definitely much smaller than the original EinStar, just a way tinier form factor, fits nicely in the hand. I got kind of big hands, and this is the iPhone 14 Pro. As you can see, it's almost the exact same size as that. Now it is much thicker, very small, definitely a good form factor. Okay, so what's really changed and what's the difference between the two? I mean, basically the only difference at the end of the day is that this one has 38 cross laser lines. So I believe there's 19 lines on each side cross-hatched, whereas the EinStar 2 only has the parallel lines for fine detail. They both have infrared and they're both wireless, and they both take very awesome little not 18650s, but what is this? This is the battery that came with it, and so I'm just gonna say 18650s, which is great because you just pop off the back and pop in a new battery. But really, there's not much to be said unless we see how it scans. So let's dive right in. I'm gonna jump over here to the computer. We'll start with the EinStar 2. I'm gonna turn it on by holding the center button here. It's got the play button and then the plus and the minus that can be used for brightness and stuff like that. And the play button can be used for other functions. So we'll turn it on. One cool thing is the same software is used for the Rockit and the EinStar 2, which is very nice. I feel like they're starting to integrate those things. So now we have the XStar Hub, which uses them all. See, let me hit plus on the connection, and there it is, pops right up. So I'll just click on it, and connection is successful. Okay, so let's scan this thing. This is kind of shiny metallic. We'll use the lasers to start out. Let's bring the scanning table in. We need a scanning table with markers because I don't want to put markers all over this object. Let's bring it in, Joe. All right, that's Joe. He's awesome. If you leave a comment below, he might be the one to respond. So this table just has a bunch of randomly placed markers. It's very important that your markers are placed randomly, because if I scan on this, which is the calibration board, and it's all symmetrical, it has no idea where it's at. So it's really important that the scanners, the markers, are placed totally asymmetrically. And then we can come into the software and do new project group. We'll call it light shroud thing. It's for a studio light. Confirm, laser scan, and there we go. So scan setting is on markers or global markers. We'll just do regular markers. We got our 0.5 millimeter resolution. Normal, I'm not going to switch to reflective. We've got acquire texture, that would be color scanning. Data quality indicator, that's always useful. We're indoors, and the local enlarged view we don't need to do. All right, so we'll just start with this. I'm going to hit the play button wirelessly. This is sweet. Okay, I'm going to sort of give it the lay of the land. It knows where the markers are. I can sort of see what my distance is. Oh, wow, it's picking up data far away. And I'll just hit go. So far, I am very impressed. This feels like an HX. This is really fast. What was that, 15 seconds? Let's see what we got. Let's check out the data. The one thing about these scanners is they do not tell you what the accuracy is. If you're a professional and you're scanning and you need accurate scans, that's where something like the FreeScan Combo is going to come into play. These units are much more robust. They are metrology grade accuracy, still a great form factor, and this thing has like 50-something lasers. It's way faster, bigger field of view. Everything's better on the professional units, including the accuracy. But that doesn't stop the EinStars from still getting very good data that you can use for a lot of different things. If you're doing projects or things like that, a lot of the times you don't need 0.02 millimeter accuracy on your data, especially if you're reverse engineering stuff. So this could be a very handy tool for a fraction of the cost. I mean, at 0.5 millimeters, we got a ton of great data. let's clean it up real quick. I'm just gonna go and do a cutting plane. Grab some of that, grab some of that, create the plane again. That should be good. All right, so let's get rid of that data, and then I'm gonna do a little connected domain just to select the object itself. All right, now I'm gonna invert and delete all that extra gunk. Boom, all right. Let's save that. Now I'm going to flip it upside down as I just did. I'm gonna generate the point clouds real quick. I should be able to create a second project where I can align the two. Yeah, there we go. All right, so we got our point. Wow, that's pretty clean, dude. That is pretty freaking clean for very low effort. All right, so I'm gonna make a new project, and that's for the other half, and then we'll take those two halves, smash them together. All right, here we go. So I'm gonna hit go. Looking good. This is really responsive for being wireless too. Guys, Shining, you did a really, I mean, so far, it's really good. It's almost inappropriately good for the price, dude. Okay, and then I'm gonna come down here at this angle, try to get some of that data. Let's get all that edge. Should have plenty for it to align with. Now, I did make a slight mistake. I don't know if anybody caught it, but if you did, let me know in the comments below. Just comment what you think my mistake was in the comment below. There we go. All right, plenty of data. You do see all this stuff. You see all this extra data floating around, but don't worry. It's still very easy. All right, so we can go like that. Hit apply. All right, I'll do another connected domain right there. Very easy. And then we will invert and delete the extra. Save that, generate point cloud, and while we're at it, I'll show you the specs of this computer because that's always good for you to know. We are running a Ryzen 9 7950X 3D 16 core processor with 95 or 96 gigs of RAM, and we have a, let's see, the NVIDIA RTX 4070 Ti in this machine. So that's how fast it is on this system. That's freaking clean, man. This has gotten better over the years. Okay, so now I'm gonna use the project's alignment. I'm gonna click on this little puzzle piece, select the first one and the second one, and then I'm just gonna use automatic feature alignment. Obviously, the auto scan did not work, so we're gonna actually go do some manual features, and I'm just gonna take, I'm thinking, which one of these was lined up with those? Okay, so what I'm looking at here is this double area and that double area. I'm gonna line those up and then figure out which one I'm at. Okay, so we've got double, hole, hole, hole. Okay, so I know where we're at now, so I can go down like this, and I'm gonna select a point right there, and a point right there, a point right there, and a point right there, and then a point right there, and right there. That should do it. There we go. Boom. Now you can see we have overlapping data, which is perfect, exactly like we want. Next, and exit. So now I can select or unselect both my projects, and then I can hide the markers just to look at the data we got. But when you zoom in, you just see the point cloud. So let's mesh that model real quick and give ourselves an STL. We can do on watertight, semi-watertight, or watertight. For this one, let's do on watertight. Preview. There we go. So we can see little areas that didn't quite have all the data, and that's going to leave holes in that area. It would have been great if it just filled that in if I selected the watertight. So let's see what that looks like. Let's do watertight. Preview. Still quick. Looks like it filled it all in nicely. So depending what you're using this for, you could pretty much go and print one of these. You could get a little more data on the top there. But dude, I mean, for what? An $1,100 scanner, $1,200 scanner? This is insane. This is like $10,000 a year ago. We get to the HX2, which seemed similar. Now the HX2 did have public accuracy data. Again, this comes down to accuracy. You're not gonna use this for inspection, but you are almost definitely going to use it for reverse engineering stuff, getting quick scans of things, getting basic dimensions. This is fantastic. I am quite impressed. Now I'm curious on this little knobble right there. Let's go back. and look at what that data is. What's causing that? So go back to the scan. Oh, it's this whole thing. Yeah. There's a bunch of data there that I missed. So I'm gonna delete all of that. Delete. All right. I gotta say, man, that's impressive. This was fast, quick, easy. So we can simplify, we can optimize the mesh, which just gives you a better, more efficient mesh. If you've got a million triangles and you want to get that down to 300,000, you can simplify and optimize. You can smooth it more, remove little floating parts, all sorts of tools in here for cleaning up the data. And again, this is the software that comes with the scanners, totally free of charge, no licenses, no subscriptions, none of that. Shining has not been a fan of that unless you get into the upper echelon of reverse engineering software. Let's just show you a little bit of measurement. We can actually do some basic measuring from like point A to point B. And you can do surface area and volume. So surface area, or the actual volume, is 178,000 millimeters cubed. And we're gonna go out, we're gonna go back home, and I'm gonna do the same thing with the rocket. So I'm gonna hold the button to turn this one off, hold the button on this one to turn it back on. Okay, there's the fan, and that one's off. Okay, and now I'm going to go disconnect and then add the little plus button. EinStar 2 is showing up, but that should switch real quick. EinStar Rockit, there we go. All right. Guys, I have just been informed that the EinStar Rockit has markerless laser scanning. All right, well, we'll test that. We're gonna test that right now. Get this thing out of here. But let's just give it a shot. Laser scan. We got global markers, we got feature alignment with 38 laser lines. So it's probably gonna use the infrared and the lasers. Dude, if this works well, this is gonna be insane. Absolutely insane. 38 laser lines, normal mode. Let's do it. So I'm just gonna scan one half of this so we can check out the data. And then we'll do it with we'll play around with a couple different things. I mean, to have laser scanning at this price point is pretty freaking good, but to have wireless, markerless laser scanning, not too bad, not too bad. Let's see what kind of data we got. Let's do another cutting plane, apply. So it's definitely muddier. Let's see what happens with the turntable. Joe, turntable. Let's see what we get when we use the turntable, because this is, yeah, it's all right. Maybe for something really rough or maybe a bigger object or something like that, that'd be fine. But let's delete the scan. We'll use markers alignment for this just to see how that goes. Same settings, same everything. I'm expecting it to be a little faster and a little more detailed. Here we go. So I'm not sure it's as fast as the HX2. It's definitely not as fast as the FreeScan combo, because if you look at the data quality indicator, the blue is where it has enough data, and then the pinkish yellow or whatever is where it needs more data. So yeah, it's good. It's not as good as the FreeScan combo. Calling me spoiled. That scanner's like 15 grand now. So for a fraction of the cost, I think I'd be happy with this. But yeah, okay, so what I'm looking at is the data in those little ridges up top, because they were super muddy on the markerless laser scan. Let's see how far down here we can get. Oh, yeah, so you still need some markers in view. No, can't quite go that far. Doing a pretty okay job on the black. Let's turn up the brightness. It's really not having a good time with that reflective black on that area. It's kind of reflecting light back, but I will say this is leaps and bounds better than the EinStar ever was. Like, massively better. Let's check this out. Let's go in here. I'm going to do let's do a markers cutting plane. So I'm gonna select a few markers. Boom, 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 and boom. There we go. I can raise the whole thing up just a little bit. Let's delete all that data. Then we'll select some of the unit itself, do a connected domain, delete that data, apply the edit, and here we have it. So yeah, if you look at that, you just see those ridges a million times better than markerless. So you do definitely lose out some data when you're doing markerless laser scanning, but the fact that you have it on a wireless unit that's less than $2,000 is kind of crazy, Okay, let's mesh that, generate the point cloud. That's going to basically take all the data and all the points and go through it and delete, throw out some of the extra data and like clean things up and make it a nice even point cloud. Ooh, that looks good. That looks real good for what it is. Let's mesh it up. On watertight. Yeah, let's preview. Not bad. Woo! That's, I mean, for a lot of customers now, I think this is gonna serve their needs just fine without spending 15 grand. And let's export the scan. We'll throw this in the description so you can download it if you want. All right, what's next? Let's do the camera with a bunch of fine little details. Let's take this thing, get that out of here. Let's pretend that we just got this, we want to scan this camera, all we got is this little mat. We're gonna put down some markers around on the mat, not on the object, to make our own little scanning table. The key here is you do not want to use a ton of markers. It's not about having as many markers as possible. I'll show you why. I'm gonna take this little thing of markers, set it next to the unit, and just watch what happens. Okay, so here's what happens when I try to scan a grid, a symmetrical grid of markers. It's the preview, okay. Oh yeah, we get the spinny screen of death because it has no idea which marker is which because it's symmetrical. It could be either one, so it just freaks out. If you have too many markers, it will ruin your scan. So we're just gonna put down a lightweight random grid of markers on this surface. Now you would not want to do this on a sheet or on a piece of paper, unless it's cardstock or something like that, because you want to maintain rigidity of the surface so that the markers are always in the same position. If these markers shift or moved around, they're no longer a locked point in space for the scanner to track from. So it's important that the scanners don't move and that they're randomized enough so that it can really tell which marker is which. So some of these I'm going to put like two next to each other so that it really knows that between this one and that one and this one and that one is not the same as this one and that one because there's this other one here in relation to it. If that all makes sense, we're just going to put, what is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It's not as good as the much more expensive scanners, as to be expected. Okay. So go in there. Oh. I'm sort of going to paintbrush over these areas. We're at a much finer resolution here, so this is going to take longer. The higher the resolution, the longer the scan's going to take. And of course, the shiny reflective glass on the back does not get picked up at all. Throw a little bit of scanning spray on this thing and pick it up like nothing. This is a dark, semi-reflective object with wireless lasers using markers. Not bad. Let's dive in. Let's do a cutting plane again. I like doing the markers because it's going to make a perfect plane based on the actual markers. Look at that. Beautiful. And then we'll come in here and do another connected domain. Just a little bit of that right there. Connect the domains. Connected domain just means it's going to assess what points of the point cloud are part of one object and select only those points, and then you can invert it and delete the rest of them. And there's not actually too much other stuff, so let's just generate the point cloud. Not bad. Pretty fine data there. All right. Again, the more time you take, the more data you get. Let's mesh it on watertight. Standard with standard smoothing. It's not too bad for 0.2. Obviously, it's a little bit more textured than the real object. You can smooth that out very easily. If I confirm, I can just go to smooth. And let's go 18. What does that do? Okay, let's go 79. What does that do? Okay, so we're losing a lot of detail. 100. See what it does at 100. Okay, nice and smooth, but probably not what we really want. So we'll just stick it down there, around there somewhere. Okay, not bad. It captures data. Very good. Very cheap for what it gets. This is pretty good looking data. Confirm. All right, and we will export this as camera 1. Spend a little extra time gathering the data and cleaning up the data. So anyway, let's get out of this and we're gonna scan a human being. Joe, you ready to model our new merch? We don't actually sell merch, but if you want the sweater that he's wearing, we got a big shipment coming in, mostly for the team and the crew. But if you would buy Vision Miner merch, let us know in the comments below. Just be like, yeah, I want a hoodie, I want a beanie, I want a sweater, I want a joggers, whatever. Hats, we got hats too. But let us know if that's something you guys want. We're a business with a YouTube channel and kind of fans and a following. It's kind of a different thing. But where'd the scanner go? So we got to start the feet, scan the plane or turn off the cutting plane function. And Joe, you know what's going to happen next?
What?
Miniatures of you printed all over the office.
Nice.
And put onto random objects.
Yeah.
Thank you, Joe. That was fantastic. Let's check out the data. What do you think? All right, Joe, look at yourself. What do you think?
It's like looking in a mirror.
Yeah, pretty much. Okay, so I could have gotten a little better under the arm in the nether regions that we won't mention, and of course the frontal regions we may not need to mention right now. But if we take this, and let's make the miniature, right? So I'll do a cutting plane on the floor. Create the plane there, drag it up a little bit, apply, all right. Okay, so now I've got that and I can show the texture. Okay, so we're looking at not bad. We could increase the brightness and whatnot on this, but we can do that all after the fact. So I'll mesh the model. We'll go watertight because we're gonna 3D print this. And let's see, medium smoothing, medium filter, 2 million triangles max, remove spikes. Yeah, let's go for it. Standard settings, not that big a deal. So texture adjustment, let's turn up that brightness. Oh yeah, there we go. A little less contrast, more contrast, all right. We got Joe in the flesh. Not bad for a low res 3D scan that took less than a minute to do. Very cool, all right, yeah. So this is now going to the print department so that we can print miniatures and hide them in random places to freak people out. Anyway, just kidding, not really. Actually, we're gonna do that. So I'm gonna do that anyway. Very good. I will export this, save locally, Joe 1. My first time using the EinStar 2 and the EinStar Rockit, and we didn't even do the tethered mode. From what I understand, and the team has told me, the tethered mode makes everything just go a little faster and a little better. So if you liked what you saw, if you plug it in, it's even better. Overall, the form factor's great, the price is ridiculous, the features, the laser, the wireless laser. I definitely buy the Rockit. Like if you're considering and you can afford it, it's an extra $500. Definitely get the Rockit for those cross laser lines and the markerless laser scanning. But if you're on a budget constraint, the EinStar 2 is still freaking really good. And man, yeah, this tech has come a long way over the last, 6-7 years we've been doing scanners now. And I think I might actually be happy with an EinStar now. If I don't need accuracy, if I don't need that metrology grade accuracy and that guarantee that it's going to be at a certain level to inspect my machined parts or something, and I just want to do fun reverse engineering projects at home on the weekend, these are pretty good units. I'm pretty excited. We'll keep doing these. We'll just keep doing more videos if you want. If you have questions, give us a call, shoot us an email. We sell all of these scanners and many more at visionminer.com/scanners. That is what we do. We are a professional business selling professional tools for manufacturing. We also specialize in high temp 3D printers for aerospace grade materials and a whole plethora of other awesome things. So check it out at visionminer.com. Thank you so much for watching. Have a positive rest of your day, and I'll see you on the next video.